Hello friends, I'm Jagdish Perk Associate. Today's topic is strength of materials. So in this topic, I'll be explaining a numerical problem from the chapter Simple Stresses and Strains. So before going to this video, please press the subscribe button of our channel, the Mechanical Engineers theme, and also click the bell icon so that you will get the notifications for new videos. Okay, so let's begin. First I'll read the question. A 0.5 meter long uniform bar with square section of side 20 mm is subjected to a tensile force of 40 kN. Determine the tensile stress, deformation and axial strain induced in the bar. Take E is equal to 200 gigapascal. Now I will analyze the question. There's a square bar. The square bar is uniform. The length of the square bar is 0.5 meter. The height of the square section in the square bar is 20 mm and the length of the square section in the square bar is 20 mm. The Young's modulus of the square bar is 200 gigapascal. Now, a tensile force of 40 kN is applied on the square bar on both the ends. Generally, when a tensile force is applied on a component, the component will undergo deformation. Tensile stresses will be developed inside the component. Axial strain will be induced in the component. Okay. So similarly here, due to this 40 kN tensile force, tensile stresses will be automatically developed inside the square bar. The square bar will undergo deformation. Axial strain will be induced in the square bar. Okay. So in this question we have to find three values, and the values are: one is tensile stress value, second one is deformation value, and third one is axial strain value. Now I will list out the given conditions from the question. First, the tensile force applied on the square bar is 40 kN and it is taken as F. Second, the total length of the square bar is 0.5 meter and it is taken as capital L. Third, the height of the square section in the square bar is 20 mm and it is taken as H. Fourth, the length of the square section in the square bar is 20 mm and it is taken as small l. Fifth, the Young's modulus of the square bar is 200 gigapascal and it is taken as E. Okay. So by using these five conditions, we are going to find the values of tensile stress, deformation and axial strain. Now I will move to the solving technique. First we will find the value of area of the square, which is taken as A. The basic formula for area of the square is height into length. So in this question we know the values of height and length. So just substitute the values. We get A is equal to 20 mm into 20 mm. So here 20 mm into 20 mm is 400 mm square. So the next step will be A is equal to 400 mm square, which means the area of the square bar is 400 mm square. So by using this area value, we are going to find the value of tensile stress. Now we will find the value of tensile stress, which is taken as sigma. Generally, the basic formula for tensile stress is tensile force divided by area. In this problem, we know the value of tensile force and we know the value of area. So just substitute the values. We get sigma is equal to 40 kilonewton divided by 400 mm square. Okay. So in this RHS, kilonewton is nothing but 10 power 3 Newton. Okay. So the next step will be sigma is equal to 40 into 10 power 3 Newton whole divided by 400 mm square. In this RHS, 40 into 10 power 3 Newton divided by 400 mm square is 100 Newton per mm square. So the next step will be sigma is equal to 100 Newton per mm square. Here Newton per mm square is nothing but megapascal. So the next step will be sigma is equal to 100 megapascal, which means the tensile stress developed inside the square bar is 100 megapascal. So by using this tensile stress value, we are going to find the value of deformation. Now we will find the value of deformation, which is taken as dl. The basic formula for deformation is dl is equal to sigma L by E, where sigma is tensile stress, L is length, E is Young's modulus. So in this problem, we know the values of sigma, L and E. So just substitute the values. We get dl is equal to 100 megapascal into 0.5 meter whole divided by 200 gigapascal. Okay, here meter is nothing but 10 power 3 mm, that is 1000 millimeter, and gigapascal is nothing but 10 power 3 megapascal. Okay, so the next step will be dl is equal to 100 megapascal into 0.5 into 10 power 3 mm whole divided by 200 into 10 power 3 megapascal. Okay, now in this RHS I am going to split the numerical terms and S units. So the next step will be dl is equal to 100 into 0.5 into 10 power 3 whole divided by 200 into 10 power 3 into megapascal into mm whole divided by megapascal. Okay, so here 100 into 0.5 into 10 power 3 whole divided by 200 into 10 power 3 is 0.25, and megapascal into mm whole divided by megapascal is mm, because megapascal gets cancelled. So the next step will be dl is equal to 0.25 mm, which means the deformation induced in the square bore is 0.25 mm. By using this value, we are going to find the value of axial strain. Now we will find the value of axial strain, which is taken as epsilon. The basic formula for epsilon is dl by L, where dl is deformation, L is total length of the square bore. In this problem, we know the value of dl and we know the value of L. So just substitute the values. We get epsilon is equal to 0.25 mm divided by 0.5 meter. In this denominator, meter is nothing but 10 power 3 mm. So the next step will be epsilon is equal to 0.25 mm divided by 0.5 into 10 power 3 mm. So here 0.25 divided by 0.5 into 10 power 3 is 0.0005, and mm gets cancelled. So the next step will be epsilon is equal to 0.0005. Okay, and this is nothing but the value of axial strain of the square bore. So friends, we have found the values of tensile stress, deformation and axial strain. Now we will store the values. So next is solution. So first is the tensile stress developed inside the square bore is sigma is equal to 100 megapascal. Second, the deformation induced in the square bore is dl is equal to 0.25 mm. Third, the axial strain induced in the square bore is epsilon is equal to 0.0005. Okay.